Now next reaction is reaction with arene sulfonyl chloride. Now what is arene sulfonyl chloride? This is our sulfonyl group SO2. This is our aryl group and here it is chlorine. So this is arene sulfonyl chloride means what? C6H5, C6H5, SO2, SO2 and chlorine. SO2 chlorine. So this is benzene sulfonyl chloride. This is also known as Hinsberg's reagent. Hinsberg's reagent. This is the naming reaction behind the name of the scientist Hinsberg, who find out this benzyl sulfonyl chloride to react with primary amine. So reaction is also called Hinsberg test because we use Hinsberg reagent, which is C6H5SO2Cl. So this is our benzyl sulfonyl chloride reacting with the primary amine. So what is going to happen? The chlorine is substituted by the whole NH alkyl group. NH alkyl group. SO2 remains as it is. This SO2 remains as it is. See, SO2 remains as it is. Okay. Only chlorine is replaced by NHC2H5 and this chlorine and this hydrogen is going to form HCl, which gives acidic H over here. Acidic H is over here. So there it is, the acidic H. Okay. And this is soluble in alkali. This is soluble in alkali. This is soluble in alkali because here it is H. Here it is H. So this is soluble in alkali. This H we directed over here. This H is gives acidic nature, and if you are going to add alkali, then it is soluble in alkali and it is neutralized. Okay, and so here the name of the compound is N ethyl, this ethyl, then this benzene, and the remaining one is sulfonamide. Sulfonamide is present. Sulfona NH with sulfonyl group, that is sulfonamide. Okay, but when there is a secondary amine, okay, this is our secondary amine reacting with benzene sulfonyl chloride, then instead of this H, as this is a secondary, means two alkyl groups are there, it may be same or different, that doesn't make any difference. Instead of H, now here is C2H5. There is no acidic H like this, no acidic H like this. So if you are going to dissolve or soluble in alkaline nature, then it is insoluble in alkali. It is insoluble in alkali. Remember this thing. Primary amine, the product we get is soluble in alkali. Secondary amine, product we get which is insoluble in alkali. This is the important part of this Hinsberg test. You have to remember this thing. See, this is benzyl sulfonyl chloride, benzene sulfonyl chloride. This is primary amine, this is secondary amine. Here it is acidic H, so it is soluble in alkali. Here is no acidic H, so this is insoluble in alkali. Next one is electrophilic aromatic substitution in aromatic amines. Okay, this is electrophilic substitution in aromatic amines. Electrophilic substitution in aromatic amines. Okay, so this is our aniline. Aniline going to react with the bromine, this Br2 in presence of HCl, then these H are electrophilically substituted by Br. Okay, Br minus, here it is Br, it is not Br minus, this is Br plus, so this is electrophilic, it is going to love this position, and here it is pi bonds are delocalized on this aromatic ring. So all these are highly negatively charged positions because all these are the delocalization of the pi bonds on this aromatic ring, and so this Br acts as an electrophile and it is going to substitute it at these positions. This is the ortho position and this is the para position. This is the tribromoaniline. This is tribromoaniline. Okay, tribromoaniline. and byproduct is thrice HBr. Okay. Now same way electrophilic substitution we can observe in nitration. In nitration we have to use here aniline, here we use aniline and bromine, here also we use aniline and nitrating mixture. We know the concentrated sulfuric acid and concentrated nitric acid gives us the nitrating mixture, and so now this is very again unique reaction where all ortho meta para positions, this is the ortho position, this is meta position, this is para position, all are substituted by the NO2. This is very important, NO2, and we get three different products. We get three different products. This is para nitroaniline, this is meta nitroaniline, this is ortho nitroaniline. All H at these positions replaced by NO2. Okay, but important thing is that para product is 51%, while the very smaller difference in between these two meta and para, this is 47%, while ortho nitro product is very less, that is 2%, very less, that is 2%. Okay, so this is the one of the method to get para, meta and ortho nitroaniline mixture by using nitrating mixture treated with aniline. To get only para nitroaniline, one more method is there, only para nitroaniline. So what we have to do over here, this aniline is going to react with acetic anhydride in presence of pyridine. Aniline going to react with the acetic anhydride pyridine. See, this is acetic anhydride, CH3 double bond O, O, C double bond O, CH3. We removed water molecule from acetic acid, acetic anhydride. So now what is going to happen here? From this acetic anhydride, one of the H is replaced by COCH3 group, COCH3 group here. So this is our acetoanilide, this is our acetoanilide. Again we are using same nitrating mixture over here, concentrated nitric acid and concentrated H2SO4 in the 1:3 proportion, and then here it is a 288 Kelvin temperature we used, and here we get para nitro. So only at this position, para position, this nitro group is going to fix, nitro group is going to fix, and on hydrolysis we can remove this COCH3 in the form of acetic acid, in the form of acetic acid, and product is only para nitroaniline. Remember this thing, when we use nitration mixture, nitrating mixture, nitration is going to take place, but there are the mixture of three products. If you want particularly only para nitroaniline, then you have to use acetic anhydride in presence of pyridine. First of all you have to get this acetoanilide, and then this acetoanilide is going to react with nitrating mixture, so you get para nitroacetoanilide. And the last reaction is sulfonation. Sulfonation of aniline, we have to use concentrated sulfuric acid, and here very interesting product we are going to get, that is anilium hydrogen sulfate. Anilium hydrogen sulfate, see very interesting, this NH2 is converted as NH3 and remaining this is H, and here HSO4 like this. So here it is H attached to here, so here it is become NH3, HSO4 are here. We have to provide heat, very specific heat, that is 453 to 473 Kelvin, high energy we have to use, and we get here NH2SO3H, this is the sulfanilic acid, this is sulfanilic acid SO3H, and aniline's NH2 primary amine group is there, but this is in equilibrium with the Zwitter ion or the dipolar ion. This is going to shift like this, going to shift like this. So in the same compound there is positive charge as well as there is negative charge. When they are going to flip off these hydrogens from here to here, this hydrogen from here to here, this NH3 is going to acquire positive charge, while this SO3 become negative. Okay, means this is the when positive charge basic group is present, when minus charge, then acidic group present. So this is dipolar ion. This identity is dipolar ion, or you may call this is a Zwitter ion, and it is in equilibrium. You may get this, you may get this. Okay, if there is a flip of the H, you get this. If there is a flip of H, you get this. Try to understand. And this is the end of our amine chapter. In the next lecture, we will start with the next chapter, and that is biomolecules. Thank you, students.